Today we'll be looking at conversion of units part 2. In the first part, we looked at a simple case study in which conversion of units is very important and the misrepresentation of units between the two parties had led to the loss of $125 million by NASA. We also looked at the three different types of systems of units, which would be the base units, multiple units, and derived units. So I'll be continuing on from the system of units. The first type would be base units, which can come under three different systems. Firstly being the SI unit, or the CGS, which is centimeter gram seconds. Basically, the meters is, instead of using meters as in the case of SI units, you are using cm. And there is also the American engineering system, and each of these have their own set of units. Multiple unit prefixes have 10 to the power of a number, which, for example, kilo is 10 to the power of 3, mega is 10 to the power of 6. It can also be used to represent a smaller quantity, such as milli, which is 10 to the power of negative 3. Here you can see in the example that 1 nanometer is equivalent to 10 to the power of negative 9 meters. Now let's look at derived units, which are base units that are multiplied or divided or both in order to get a derived unit. So one example is energy, whereby 1 joule is equivalent to 1 Newton meter, and newtons itself, which is a unit of force, can be represented as, from Newton's law, F equals to ma. So my m is kg, acceleration meters per second square, and that you have another meter for energy, so I'll just use E to represent energy, and I would have kg multiplied, so this would give me E equals to kg ms. So this is how this top part has been derived. The next important part of this topic is conversion factors. So conversion factors are important because they are the values which can be multiplied with another value of a different unit in order to get a derived unit. Here there are different conversion factors for the different quantities. These would I can better illustrate this with an example, and it will be much more clearer when I do that. So let's look at a first example, which a very simple example. I would want to convert 0.02 meters into centimeters. So how am I going to do that? I know that 1 meter equals to 100 cm, and this is because another way I can represent it is that centi is equivalent to 10 to the power of negative 2. So if I wanted to say 1 meters, it would give me m. So if I want to convert this to centimeters, I would have to apply a conversion factor of So if I want to convert my 0.020 meters to centimeters, I have to multiply it using a conversion factor. I would put one easy way to remember is using this technique which I've learned, which is the new unit over old unit. So new unit over old unit, in which now I would say I have to put 10 to the power of 2 cm because this is my new unit, and 1 meter. So this here is my conversion factor. So this would give me 2 cm. So this is just a simple example. We can look at more difficult examples. Another example would be to convert 23. Let me use so I want to convert this. So this is my example 1. For example 2, I have 23 lbm multiplied. So this is basically so let me just look at the chart now. I would want to convert this to kg cm second square. Okay, so now if I look at this, I can use this values which is given as 1 pound mass equals to 400 0.453593 kg, and so I have my first conversion factor. Another conversion factor I would require is for my length. So from here I know that the second conversion factor will be 1 meters equals to 3.2808 feet, right? And then yeah, so this is good to go. I can also use a conversion factor later to convert my meters to centimeters as required here. So with the conversion factors in place, I can start applying them. 23 pound mass equal, I can multiply it first to convert it to kg. So my new unit is 0.453593 kg over 1 lbm multiplied by feet, which would be 1 meter equals to 3.2808 feet, and I also need to convert my units of 1 minute equals to 60 seconds. So I would have to multiply this by the old unit first. The reason being so that it would cancel out. So I'll show how that works. So I have to take a square because the unit here is given in terms of square. So if I were to use a calculator to work out this value, okay, so now let me show you why whatever I did works by putting the old unit over a new unit. If let's say the unit here is actually in the bottom portion of the fraction, because now you'll have 60 seconds square, and this would be 34.227 times 1 minute square over 600 second square. So now I would be able to just cancel out the unit of minute square, so I get the value of 0.009575, and the units, final units, it's kg meters second square. Are we done? No, we're not done, because what they actually require is cm. So I further need to do a conversion. Fourth one is that 1 meter equals to 10 to the power of 2 cm. The mistake